Hey, welcome to this battle review. And we were talking about how the work is combated into kinetic energy and potential energy. Then we have to recognize this point, right? Now, let's check it out. First part that we were talking is A. We are saying that in this part A, the potential energy is maximum. Why, Fisher? Because if we recall its equations, the potential energy is equal mass per gravity per height. Then this height is the maximum amount of height, right? This is the maximum amount. That's why the potential energy at this point is the maximum, right? Now, the kinetic energy obviously is zero because it has not started moving yet, right? But the potential energy is maximum. Then the work produced or the work made to put this object up to here from the ground. And now we gotta recall what is the work equation, right? Work it's equal force per distance, right? Let's recall this. Work is transformed into kinetic energy and potential energy, right? Then at this point, its maximum, the kinetic is minimum or is zero. At this point, B, where the weight amount is zero or the work coordinate is zero, the point is lower, right? It's the minimum amount of the potential energy, but it's the maximum for kinetic energy, right? If you got some questions, come ask them on the comments below. I will be more than glad to help you out there. So at this part at C, we are saying that yes, the potential energy is increasing and the kinetic energy is decreasing, right? It's like increasing, decreasing, because the sum of both is equal to the total of energy of the system. Because recall this, the energy cannot be created, neither destroyed. You just gotta be transformed, right? Like this video, if you have liked it. And now this part, the Z part, the potential energy is increasing and the kinetic is decreasing, right? Now say potential energy at this part, potential energy increasing and kinetic energy decreasing, right? At here we have to have some concept called centrifugate force, right? Centrifugate force, and to grasp this, to catch this, we need to understand its equation. Centrifugate force is equal weight multiplied by velocity of the squared or squared radius divided by radius, right? Which radius? This radius, this loop radius, right? This loop radius, to avoid that the gravity falls down or take this down, we have to have a centrifugate force that will be the one in charge to make me be stable while I am breaking the gravity, right? Then if I am breaking the gravity, at this point, the force that maintain me there is called centrifugate force that must be equal or higher than gravity to avoid me falling me. I don't want to be falling. I need to be higher. Then at this point, the centrifugate force is higher, is equal, it's higher than, with superior than gravity, right? To avoid falling. That's why the centrifugate force must be higher than gravity, right? Then, and here at this equation is pretty simple. Weight multiplied by velocity divided by radius. Then that's all up to weight, right? Now let's recall something. What is the potential energy? The potential energy is the one related to how much high I am. And it's product of transfer the work that I make to put something from somewhere to anywhere, yeah, then I will make some work, and that work will be transformed into kinetic energy and potential energy. And that the potential energy, its equation is potential energy is mass per gravity per height. How much height, how much mass multiplied by the gravity multiplied by how much height I am or the object is regarding the ground, right? Now, at this point, we also need to recall what is the kinetic energy about. The kinetic energy is the mass multiplied by velocity squared divided 2, or also up to a square. Then it means that the kinetic energy is the energy related to motion, right? And the potential energy is one related to height and motion. Height, motion, the height motion, right? Now, if you got some questions, please don't hesitate to ask them on the comments below. I will be more than glad to help you out. So let's record this in a simple way, right? And let's do something on this. I have here, and I'm going to throw this razor, right? And it's here. Yes or yes, I will make and work to put this from this to this. There's a job. There's a work, right? There's a job. There's a work, right? And this work has been turned or has been converted into potential energy and kinetic energy. At this point, the potential energy is maximum, but when I throw this, look at this. At this point, the potential energy is less, but the kinetic energy is higher, right? Like increasing, decreasing. Potential energy decreasing. Kinetic energy increasing. Yes, you got it, like at the point that has touched the ground is the highest kinetic energy expression. That's why it has sound like because it has at that time the kinetic energy was maximum. So you have to grasp this point. Work transforming into potential energy due to how much high I am regarding the ground, and the kinetic energy regarding how much velocity do I have regarding how much high I was. So let's record this. If I wanna throw this away again, I will need to make a work. Which work? The work to put this up to here. Now it has converted this work into kinetic energy, right? And now this kinetic energy has been turned when it's falling, it's increasing the kinetic energy. It's increasing. At this point, the kinetic energy is increasing. But the potential energy is decreasing, right? Now let's resume this in this way. Potential energy, kinetic energy. Potential energy here increasing. Kinetic energy increasing. That's why the kinetic energy here is the maximum and the potential energy here is the minimum. You got some questions? Don't hesitate to ask them on the comments below. I will be more than glad to help you out. Let's record this part that perhaps is harsh to understand, right? But this part it's a piece of cake because if you have this form and you are making this loop v at this point, the gravity you will need to make an effort higher than gravity, yeah, to avoid falling. And this force or positive to gravity at that point of the force that maintain me there without me falling is called centrifugal force, right? That is the force related to a loop. Okay, then that loop, that force related to a radius, right? To a cycle, also a circle. That's why in its equation, it's one of the one of the components of this equation is the radius, right? Now the centrifugal force is the one that help me out avoid falling at this part, right? You have good questions? Ask them on the comments below. I will be more than glad to help you out and see you there in the next video. And please don't hesitate to ask me. So it's time to cry the books. See you there in the next class. Please write this down.